Hello dear fans. How mass increases with acceleration. In the classical consideration of the movement of bodies, there is no need to consider the dependence of such a physical quantity as body weight on changes in speed, except in cases of increasing body weight. Relativistic consideration. Open your grade 10 physics textbook on relativistic dynamics. This section of physics describes the processes and patterns that occur when bodies move at speeds close to the speed of light. The fact is that when bodies move at such high speeds, some of the physical quantities that are considered constants in classical physics become dependent on the magnitude of the speed. However, note that the change in body weight during movement at ultra-high speeds is associated with a large value of the speed, and not acceleration. If you look at the expression for the relativistic mass, you will see that it depends precisely on the magnitude of the velocity vector. The acceleration of bodies in relativistic cases leads, rather, to time shifts. Weight gain through acceleration. Note that as the body accelerates, in some physical cases, the body weight changes. Such cases, for example, include the movement of a person in an elevator. When the lift begins to accelerate in the upward direction, the person experiences an increase in their own weight. In a situation where the elevator slows down, moving up, it seems to a person that its weight is much less. In fact, the sensations that a person experiences in these cases are quite valid and can be easily described by classical dynamics. Draw on a piece of paper a sketchy elevator in the form of a rectangle and a person inside it in the form of a point. Draw the vectors of the forces acting on a person when moving in an elevator. In this case, the person is affected by the force of gravity directed vertically downward and the reaction force of the support directed upward. The weight of the body is considered to be the vector that is opposite to the vector of the support reaction. The frame of reference associated with the elevator is not inertial, so the forces do not compensate for each other. Write down Newton's second law by equating the product of a person's body mass by its acceleration in an elevator to the sum of force vectors. From this ratio, you can find what the reaction force of the support is equal to. It will be equal to the product of the body mass by the difference between the acceleration vectors of the elevator and the acceleration of gravity. Now you can move on to the expression for the weight simply by swapping the two types of acceleration. If the elevator accelerates, moving up, then when projecting the acceleration vectors on an axis directed vertically down, you get that the two types of acceleration are added, not subtracted. Thus, it turns out that with an accelerated upward movement of the elevator, the weight of a person increases by an amount equal to the product of the body weight and the acceleration of the elevator. This leads to feeling overwhelmed. Thanks for watching.